This is the full code. I will also attach it to the course. Now for the simulation, I'll start by attaching the free running clock. Then I will enable the clock to run. Then the board select signal will be set to 0, which is the fastest board. The board clock is now clocking the board generator. So the board generator output, which is the board clock, will now be clocking the transmitter. Now when I reset the circuit, and then I will set the RTS signal on, then you find out that the TS bit signal is steadily on or high, which is the characteristics of the transmitter receiver line. Is steadily high when no transmission is working, until I turn on the RTS on. But I'll first of all put an arbitrary input. I will turn on the RTS signal. Then I will put an arbitrary input in the DOUT input. Then whenever the RTS signal is on, it means ready to send, that the transmitter is now sending data. And you can watch the TS bit going on, off, transmitting the data. If the stop bit was set to 0, the transmission will occur multiple times. Once it ends, it resumes again. But here is set to 1, and is tied to high or 1. So what happens is, once it's done transmitting for the first one, it stops until I reset it and it starts back afresh. So I will repeat it with a different baud rate. You can see it's now 1, it's no longer 0. So, and this is actually slower than the first one. So you'll notice that the TS bit comes on and off at a slower rate compared initially when the baud rate selected was 0. So in our next lesson, we are going to dive into the transmitter and see what circuitry is contained inside it. And we would also write the vhdl code. Next.